Assalamualaikum and hello to my lecturer Dr. Nadia Wahi and all my fellow friends. Today I would like to present my research proposal paper, and the title is Exponential Sums for 11th Degree Polynomial. For introduction, polynomials are algebraic expressions that involve a sum of powers in variable multiplied by coefficients. And so, in my research proposal, I would like to propose how to find the exponential sums of 11 degrees polynomials. So this is three definitions or symbols that I will use throughout my research proposal paper. First is ZP. ZP is defined as the ring of p-adic integer. Then omega p, the completion of algebraic closure of the field of rational p-adic numbers qp. And lastly is odd px, is the highest power of p divides x. Okay, next. This is the literature review. First is Loxton and Smith, 1982. According to Loxton and Smith, 1982, the cardinality can be determined by the p-adic size of common zeros of partial derivative polynomials associated with f in the neighborhood of points in the product space omega p n, when n greater than 0. And Loxton and Bogan, 1985, the estimation of exponential sums by using the number of common zeros of partial derivative polynomials with respect to x modulo q. Next, Muhammad Attan and Loxton, 1986, they claim that Newton polyhedral method used to obtain the p-adic size of polynomials in omega p xy, which is an equivalent to Newton polygon in Copley's 1977. They evaluated the cardinality for certain low-degree polynomials fxy over zp. It's Muhammad Attan 1986, Chan and Muhammad Attan 1997, Heng and Muhammad Attan 1999, along with Sapar and Muhammad Attan 2002. All of them use Newton polyhedron technique for lower degree two-variable polynomials. But for the higher degree polynomials, the results are less accomplished, or it is less accurate. Next, Sapar and Muhammad Attan 2009 and Sapar et al. 2014. They use the Newton polyhedron technique to estimate the p-adic size of the polynomials under considerations. And then, Yap et al. 2011. They claim that by using Newton polyhedron technique, the p-adic size of common zeros of partial derivative polynomials associated with a cubic form can be found explicitly on the indicators diagram. Okay. Next, Sapar et al. 2013, they investigated the estimation of p-adic size of common zeros of degree 9 polynomial. Next, Aminuddin et al. 2014, they continued the research of Yap et al. 2011 on a complete cubic form polynomial. Sapar et al. 2014, they researched the estimation of p-adic size of 8-degree polynomial. Zuckerberg et al. 2015, they then investigated a method to determine the p-adic size of factorials. Lasaraya et al. 2016 and 2016. Okay, here, these authors produced two journals or two articles about the cardinality of 12 and 11 degree polynomials respectively. Uh, then, yep, at all 2019, they obtained the periodic size of partial derivative polynomials associated with quartic polynomial, and using the result, they get the estimation of exponential sums of the quartic polynomial. And look at all 2020, they acquired the estimation of exponential sums for 8-degree polynomial, and they researched the estimation of exponential sums for 7-degree polynomial. So from this literature review, we can say that we can talk about we can say that Newton polyhedron, which is how to find the periodic size, and cardinality, estimation of cardinality, is important to find the exponential sums for some degree polynomial. Okay, next, my research question for my paper is, can we use the estimation of cardinality to calculate the exponential sums of 11-degree polynomial? Okay. So here, there are 3 objectives that I want to achieve. And the last of this research proposal, which is to determine the periodic size of common zeros of partial derivative polynomials associated with 11-degree polynomials by using Newton polyhedron technique, to estimate the cardinality of the set of the solution, and lastly, to estimate the exponential sums of 11-degree of polynomial. Okay. Next, the methodology. So basically, this is the main 3. This is the 3 method that many researchers use to find the exponential sums of degrees. Okay, but the important challenge is to find how much classes of degree polynomial that these methods can hold. So go to the first method, which is Newton polyhedron technique. This technique is used by Muhammad Attan and Lockstone 1986, and also many researchers use this technique for lower degree to variable polynomial, and also the higher degree of polynomial, but unfortunately, the higher degree polynomial are not less accurate. So this technique used to determine the estimation for the periodic size of common zeros of the partial derivative polynomials fx, fy, which derive from fxy. And in this technique, we have 2 theorems and 3 lemma. This is the theorem 1. Okay. This is lemma 1, which is we have one equation here. This lemma 1. This is lemma 2. Okay, we can see that we let p greater than 11 be a prime. It is because we want to have an degree 11 polynomial. If you want to have 7-degree polynomial, we can use let p greater than 7 be a prime. And this is lemma 3. So actually, these 3 lemma are related to each other, because when we can see, when to prove lemma 3, we need the result from lemma 2. So from this lemma, we need to prove this lemma, so that we can use the result for the next lemma. Okay. This is theorem 2. Okay, actually, those lemmas, those three lemmas are needed to prove our main result in theorem 2. So basically theorem 2 is our main result. You can see here, let fxy, ax11, bx10. So basically this is the polynomial. Okay. The next, second method is estimation of cardinality. Okay. In estimation of cardinality, we have two theorems, theorem 3 and theorem 4. Okay. So Loxton and Smith, 1982, proved that we can get the NFXFY PA from the p-adic size of odd P x minus Ci and odd P y minus eta I by the following theorem. This is the important theorem. Okay. Next is theorem 4. Okay. This theorem gives the estimate of the cardinality associated with fxy, fxy. Theorem 4 is the cardinality. Okay, next is method 3, estimation of exponential sums. Theorem by Momaatan 1984 that can be used for estimate the exponential sums. So the cardinality can be used to find estimate for exponential sums associated with polynomial of degree 11. Okay. We can see here theorem 5 at the last sentence. If A is odd, then use theorem 6. So in this method, we have two theorems. Okay. So you can see here for A greater than 1 and theta equal to A minus 2. So this theorem is for even number, and this theorem 6, which is used for odd number. Here we use beta, and for theorem 5 we use theta. Okay, and we can see here the equation are still the same. Okay, next, expected result. So there are three expected results that I propose, which is Newton polyhedron technique and estimation of cardinality are expected to be used to find the estimation for the exponential sums of the 11th-degree polynomial. Then, by theorem 5 and theorem 6, we are expected to have the result estimation of exponential sums of the 11th-degree polynomial. And then, lastly, we predict that the proposed method is unfailing to solve the exponential sums of the 11th-degree polynomial. Okay. So this is reference. There are 5 journals or 5 articles that I use to complete my research proposal, and these five articles and journals, I compare it, and basically these articles have same information, so I need to compare it. Okay. So okay, thank you. That's all for my presentation. Thank you for watching.